Now we are taking another example of this quadratic inverse there. Let's say y equal to f of x, and that thing is equal to 4x square minus x minus 3. Let y equal to f of x, then x is equal to f inverse of y there. So it means you are making x as subject from this equation. Now we are using, in the first two, we have explained the simple method with the completing square, and now we will follow the third method, which is directly we can do the inverse of that quadratic there. Y equal to 4x square minus x minus 3, or 4x square minus x minus 3 minus y equal to 0. Now, this 4 is the value of a, this b is value is minus 1, and this c value is equal to minus 3 minus y. The rest of things we are taking it as a constant there. We know that the quadratic formula is, if x is a subject, then it should be equal to minus b plus minus b square minus 4ac square root over 2a. Now, we put all these values into this, then x will be equal to minus b, which is minus 1. So that will become plus 1 plus minus b square, that is 1 square, minus 4 into a is 4 and c is minus 3 minus y divided by 2 into 4, which will become equivalent to 1 plus minus 1 minus 16 and minus 3. So 48 plus this minus and minus plus 4 fours are 16 y over 8. Or this thing will become 1 plus minus 16y plus 49 divided by 8. But we know that x is itself equal to f inverse of y, so it should be equal to 1 plus minus 16y plus 49 square root over 8. Now replace y with the x, so f inverse of x is equal to 1 plus minus 16x plus 49 square root over 8. So this is the inverse of that quadratic expression, where if it is more than that value of the turning point, then it should be taken as plus, and if it is less than that turning point, it should be minus there. And the condition here is 16x plus 49 should be greater than or equal to 0, or x should be greater than or equal to minus 49 over 16. So this is the condition for this, so that the inverse of that quadratic will exist there. So it is an alternative method for using the quadratics in terms of the quadratic formula for the inverse of that function there.